Hi everybody, this is Mrs. Weens and this is your first video of advanced functions. So just like we started grade 11 functions, we're starting today with an overview of what a function is. So the definition of a function. Hopefully you remember. So I'll be using, this is the note that we're talking about today, functions and overview. So the red, what's written in red here, is what you're actually supposed to, what you're supposed to fill in your note. So you'll see that that's where the blanks are. So it's up to you, but you might want to, what was I going to say? You might want to just pause the video and copy everything first so that you're able to just listen to me as I explain the concepts, but that might be a personal preference for you. So a function is a relation where there is a unique output for each input. So when you put something into the function, you only have one possibility of what can come out. So yeah, we'll get to some examples of what that looks like in a second. Each value of the independent variable must correspond with one and only one value of the dependent variable. Okay, so when you put in an x, you should only get out one y. Now, that doesn't mean that the same y won't happen more than once, okay? So like in a parabola, for instance, let's say, for example, let me just get the pen here. Let's say, for example, y equals x squared. This is a function because if you put in any number, let's say 1, you're only going to get one possibility for what you can get out. 1 squared is 1. There's nothing else that 1 squared can be. But the answer 1 will come up again if you put in -1. So both 1 and -1 as input will give you an output of 1, but that is still a function. The problem would be if you had an input of 1, let's say, that came out with 2 possible outputs. That is a big no-no. Okay, so hopefully that brings back some memories for you. There is an example on page 7 of your textbook, so you should look at that either now or in class if you don't have your textbook with you. So now we can get to the examples. So graphically, an example of a function is anything that passes the vertical line test. So for instance, you can have something that can look really strange like this, and we'll get into this later. This is called a cubic function, but it passes the vertical line test. So what that means is if we took a vertical line, like a ruler here, so like, I don't know if I can do this. Let's try it. There's a vertical line. Now, if I wanted to grab it and move it over left and right, you'll notice that everywhere I touch, it only touches the function at one part. There's no time where that vertical line touches the function in more than one spot. Okay, so that means for every x, you'll get one y. Notice that a horizontal line test doesn't have anything to do with the function because you can have the same y value more than once. It's the same, an x having 2 y values, that's the problem. So this is a function, yay, because it passes the vertical line test. Now, something that's not a function, our classic example would be something like this, which we did last year, because this clearly fails the vertical line test. So if we bring this vertical line, if we bring this vertical line over here, you'll see that at this point, it just touches one part of the graph, but oh no, blah, 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 it's touching twice. So look at this, it's touching the function here and here. So this x value of, like, let's say -1 yields 2 different y values. Can't have that, not a function. Okay, a numerical example, numerical is just a fancy way of saying table of values. So if you have your x and your y, let's say, you put in -2 and you get out 4, and you put in -1 and you get out 1, and you put in 0, you get 0, 1, you get out 1. Okay, every x value just corresponds to one y value. Again, the y value of 1 comes up twice, but that's okay. Doesn't matter. The fact is that each x value only has one buddy. Okay? So a non-example, which you're going to be like, Mrs. Weens, I've never even seen this. Well, that's because we only really deal with functions. Is let's say -2 corresponds to 4, and -1 corresponds to 1. But let's say 0 could be 0, or it could be 7. Not a function, all right, because that x value has two y values, 0 and 7. Algebraic is just a fancy way of saying, I'll get back to green here. Oops. Look at all these things I can do. Algebraic is just another way of talking about equations. So any quadratic is a function. We know that. Anything that's linear, so even if it's in standard form like this, that's a function. Any reciprocal guy is a function. Okay, sinusoidal functions, of course. All right, those are all functions. Isn't that just great all time? Now, when you know something is not a function is when you get something like this. Y equals, let's say, plus or minus root, what do I have here? 2x minus 3. Okay, it's not a function because this plus or minus means that when you put in a value of, let's say, x equals 6, you would get 2 times 6 is 12. 12 minus 3 is 9. So the square root of 9 is 3. But you would also have to take a negative version of that, which is minus 3. So because the x value of 6 yields the value 3 or negative 3, that's not a function. Okay? Or you might have something rewritten like this. X squared plus y squared equals 16. Now in this case, there's no plus or minus, but if you were to rearrange for y, okay, just think about that. You would have y squared equals negative x squared plus 16. Sorry, y squared. And then to get y by itself, you would have to square root, which means you have to take plus or minus square root because you're undoing a square. So you'd still end up with the same situation. All right, so if you see a y squared that you have to rearrange for, that's also not a function. Okay. So let's recall our definitions of domain and range. Domain are all possibilities for the independent variable. So when you're looking at the equation, you're thinking, what x's can I put into this equation without breaking it? So if it's a linear or a quadratic, you can put in anything you want and you'll get an output, okay, unless it's a realistic situation. But something like a square root function, let's say, oh, see, now my dog wants to go out. Just ignore her for a bit. What was I going to say? Yeah, a square root function, so y equals square root of x. X has to be greater than or equal to 0 because you can't take the square root of a negative number. So you have to think, what am I allowed to put into the function? Now, range is what is possible for the dependent variable. So that is what y can be. So what are the possibilities of what can come out of the function? So that's, if you're looking at a graph, let's say, of a parabola, when you're thinking about range, you're thinking up and down because you're thinking, what can y be? So you have all these possibilities. Y can be anywhere up here because that's what the arrows mean. Boop, but then past whatever this y value is, the function no longer exists. So the range is restricted by that lowest point. So when you're thinking domain, think how far can I go left and right, or is there anywhere where I can't go in my x's? And when you're thinking range, how far can I go up and down? Is there anywhere where I can't go with my y's? So here's some important terms. An asymptote, if you don't remember, that's something that you get, a line that you get really, really close to but don't touch. So, oh, that's bad. But remember, for reciprocal functions, they would look something like this, except not on so much of a strange angle, Mrs. Weens. So this would be a horizontal asymptote. So let's say that's x equals 2. Okay, because it gets really, really close to 2, but doesn't touch it. And this would be, sorry, that'd be y equals 2. Okay. And this is something it gets really, really close to and doesn't touch. It's a vertical asymptote. Let's say this is x equals 3. So you can put in anything you want to up to 3 on either side of 3, but you can't put 3 into the function. So the domain for this function would be x such that x cannot equal 3, but x is in the set of all real numbers because I can put in any number I want, decimal, fraction, whatever, negative. I just can't put in 3. The range then would be y such that y cannot equal 2, but y is in the set of all real numbers, so I can do anything else I want, just not 2. All right. Let's go to the next page. So here's some examples of a few different types of functions. We can talk about how to determine the domain and range of these functions. Now, there's 2 ways of thinking about this. Well, I'm sure there's more than 2 ways, but 2 ways I would recommend. First is thinking about it algebraically, and the next is thinking about it graphically. So the algebraic way is a bit more logical if you kind of have a more logical mind, and the graphical way is more visual if you need to like see things or things need to be a bit more concrete for you. So I'll start with the algebraic way. So you got to think about here. Notice that I factored out k. Okay, because then I'm able to better see what's going on with my domain. So with a square root function, I just need to think that whatever is under the square root cannot be equal to a negative number. So it has to be non-negative. That's 0 or positive. Notice I don't say it has to be a positive number because 0 is included in this. It can be 0. So we say it has to be a non-negative number, which includes all positive numbers and 0. Small technicality, but it's there. So we can make a little note here. Must be greater than or equal to 0. So therefore, I can kind of just think logically, what would give me 0 here? So if I had 2, x minus 5, what would give me 0? And that would, of course, be x equals 5. Okay, if I put in 5 there, I'd get 0. So then I think, does putting in higher numbers than 5 get me going in the right direction? Or does putting lower numbers than 5 put me in the right direction? So what I do is I literally just try one on above 5 and one below 5 and see what works. So if I put in x equals 5, then I get, I should have just written f at 5, but f at 5 equals 0, right? So that's what we just did. But if I put in something just above 5, so f at 6, do I get a positive or a negative number? Well, I get 6 minus 1. 6 minus 5 is 1. 2 times 1 is 2, etc. That's going to work. That's not going to break the function. So that gives me a positive number. So now I can check f at 4. I mean, but at this point, you don't really have to because you should be able to reason, well, lower than 4 is lower than 5 will give me negative. So 4 minus 5 is going to give me negative 1. That's 2 times negative 1. Negative 2, I get a negative under the square root. Error. Does not work. Okay? So, bloop, 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 bloop. We don't like you. So therefore, the domain is x such that x has to be greater than or equal to 5. And x is in the set of all real numbers. Yay. Okay, so now I need to think about the range. So I'm going to go over here to do the range since I didn't leave myself much room there. So the range is anything that y can be. So now we have to remember that, let's do some purple here, anything that comes out of this section, so anything that's in the square root and multiplied by anything, the lowest it can be is 0. So the lowest output I can possibly get out of that is 0. So since the lowest thing I can possibly get out of that is 0, the lowest thing I can get out of this entire function must be 1. And then I know that it's all above 1 because this is a positive 3, so that means the parabola is opening up. So it's going to look something like this, right? So I know that it's all going to be above 1. So my range is y such that, oops, no, pen there. There we go. Y is greater than or equal to 1, and it's in the set of all real numbers. Okay, so that is kind of the algebraic, logical way of thinking about it. But for all you graphical people out there, there is hope. So think about this is just a square root function. Okay, we know what a square root function looks like. Hopefully you remember from last year. It has this basic shape, right? So we can just think about how it's been transformed. So it's been stretched by 3, whatever. It's been compressed by 2, whatever. What matters for domain and range is how far it's been moved over, like left and right or up and down, and if it's been reflected in either direction. So it hasn't been reflected, but it's just been moved to the right 5 and up 1. And then it might have a different shape, but that doesn't matter for domain and range. So it's been moved to the right 5, so that's 5, and up 1. So then you can just see, oh, it starts at 5 and goes in this direction, and for y it starts at 1 and goes up. So then you can just come up with your domain and range that way. Alternatively, you can go to GeoGebra, okay, and you can type in the function f at x, just as it was given to you initially, 3, and then you have to write times square root, okay, and then that comes up, SQRT is what you need to write, 2x minus 10, I don't even need to factor out k, and then put my plus 1 on the outside, and then you can see where it is there, okay? So it starts at 5 and then goes in that direction, starts at a y value of 1, goes in that direction, so you can see your domain and range, okay? All right, so that is that. That looks pretty messy. Sorry, guys. So let's go to a reciprocal function. So in a reciprocal function, there's always one value that x cannot be and one value that y cannot be. So again, you can just inspect it. So you can just ignore these other two things I wrote here. You can just look at it and use logic, or you can think about it graphically. So in this case, the logic is actually much simpler than the graphical explanation, whereas here I think the graphical was actually easier. But look at this. Basically, when you're looking at this, you just have to think that the bottom cannot be equal to 0. Why? Because you can't divide by 0. So you just see, oh, well, what would make that bottom 0? It would be x equals 1. So therefore, x cannot equal 1, and that's your domain. X such that x cannot equal 1. But x is in the set of all real numbers. So then your range is y such that, okay, what cannot come out of this function? You have to think about that. Now, whenever you have a little guy bundled like this, a number over a reciprocal like that, basically this whole thing can never equal 0. Because you can, no matter what you divide 5 by, you're going to get a number. You'll never get actual 0. You can think about why that's true. And since you're not adding and subtracting anything, then that's just what y cannot be. Y cannot be 0. Okay. Now, if you're thinking about this graphically, recall that a reciprocal function just looks like this. There's the parent there. Okay, and when you factor out k, which I did, so I moved it so that the x value was first, just to make it less confusing, and then I factored out that -1. This just means that the whole thing was moved to the right one. So we don't have any moving up and down, just to the right one. So basically it's here and here. So here's your asymptote at x equals 1. So you can see why it is what it is. Okay, last one, this is a quadratic. So notice that it's in vertex form. This is a huge help because we see that the vertex is 3, 45. Okay, 3, that's the x value, 45, that's the y value. But we also notice that it opens down. That's a huge thing. Okay, see this? It opens down since your a value is negative. So therefore, if you draw a quick little sketcheroo, okay, 3, 45, and then it opens down. Okay, we can see that our t is such that, this is our domain, sorry, t can be any real number. Now, this might not be true because if t represents time, which I'm guessing it is, it would actually be that t is such that t is greater than or equal to 0. But we're just making that assumption that that does represent time, but I mean, that's a pretty safe assumption. So all this stuff wouldn't actually be involved. Okay. Now height for sure has to be less than 45. Now, could height be negative? Well, it depends what height represents. If it's height above the ground and it's a ball, like something that can't dig into the ground, then height would have to be between 0 and with a max of 45, right? And then height can be a decimal, so that's good. But if this was height above the water, then you would just have height is less than or equal to 45, and you would take that out. Okay, so it really depends what context height is being represented in. All right, one final thing is function notation. And I have most of this done for you. So f at x there means f of x or f at x. I think I say f at x more commonly. F is a function of x, so f is the output of a given input x. So for instance, you could say wages is a function of hours worked. Okay, f at -1 means what is the function when you put in x equals -1. So what is the y value when x is -1? How high is the graph when you have put in an x value of -1? F at x plus 1, though, is something a bit different. That means that you're going to be replacing every x with an x plus 1. So now instead of the input being x, where here we say f at x is x squared plus 1, where the input is x, now I want the input to be x plus 1. So instead of an x here, I'm going to put an x plus 1. Okay, and then I can either just leave it like that, or if it says to simplify, then I would expand this to x squared plus 2x plus 1 plus 7, which is x squared plus 2x plus 8. All right. We use function notation because it's a lot more flexible than just y equals, and it can be used not just with f and x, but with lots of different letters like h at t, for example. So that's your basic overview. I know the domain and range part took quite a while, but that's a key part that I find students have trouble with, so that's why I spent so much time on that. I'm so glad that we're back to doing this this video recording. I hope you guys like the new style. It's a lot easier for me to record, and I think it gives us a lot more flexibility to see different applications on the computer screen. So thanks for watching. I have to say it. but I really do hope you learned lots.